We're in section 4-2, Method of Elimination, and this is part 2. We're starting at problem 18. Okay, well, let's see. X prime is equal to x plus 2y plus z. Y prime is equal to 6x minus y. Z prime is equal to minus x minus 2y minus z. Okay, well, if we look at these two equations very carefully, we see that if we subtract them, so I'm subtracting them, we're going to come up with x prime is equal to z prime. And if x prime is equal to z prime, so that means z prime is equal to minus x. Okay, so if z prime is equal to minus x, so z prime is just going to be minus x, then x prime has to equal 2y. So z prime is equal to minus x, and x prime is equal to 2y. Okay, so then we're going to take that and we're going to combine it with the second guy down. And we're going to say that y double prime is equal to 6x prime minus y prime. Okay, so y double prime and 6x. Okay. And then, we're going to do that first. We're going to do that first, and then we're going to take and apply that x prime is equal to 2y and come up with y double prime is equal to 12y minus y prime. And at that point we can rearrange y double prime minus 12y. Try that again. Y double prime plus y prime minus 12y is equal to 0. Now I have a characteristic equation. M squared is equal to m, let's say plus m, minus 12 is equal to 0. I can factor that m, minus 4m plus 3. M is equal to solution set minus 3, 4. And y of t is going to be c1e to the minus 3t plus c2e to the 4t. And we better go back and do that again. This is a plus sign. This is a minus sign, because I want this to be negative and I want that to be positive. This is plus, that's minus, that's minus, that's plus. Oh well, so much for sleeping out of doing the problem. I'm going to have to try to stay awake. Now, we're going to go back to, so now I know what y is. And if I come back up and I say, see this problem, we'll change the grade. I'm going to bring this guy down, the middle one. And we're going to rearrange him and say that x is equal to y prime over 6 plus y over 6. So x of t is going to be 3c1 e to the 3t over 6 minus 4c2 e to the minus 4t over 6. And I can rewrite that to be something different, like 1/2 c1 e to the 3t minus 2/3 c2 e to the minus 4t. Okay, so now I know what x is, and I know that, coming back up to the top, that x is going to equal z prime. Z is equal to minus z prime is equal to x minus x. Okay, well, we're going to come back up to this equation and say, well, if x prime is equal to z prime, we probably can't say that. Okay, so back to the bottom. I know x, I know y. I should be able to calculate z. And come back up to here. If x prime is equal to z prime, then that implies that z is going to equal to minus x. And we're going to just use that down here and say z of t is going to equal 3 over 2. 2 over 3 c2 e to the minus 4t minus 1/2 c1 e to the 3t. And when we look in the back of the book, that checks with back of book. 18. Okay, number 24. I'm going to do something a little bit different. We're supposed to determine whether or not the system is degenerate or not. System degenerate. I like that word. We're going to use it again in this chapter, in the next chapter, chapter 5. System is degenerate or not. Well, what does that mean? That means either there's no solutions or there's infinite many. Infinitely many solutions. So infinitely many is sort of like not having enough or whatever. On page 243 in the book, you're going to find there's such a thing as an operational determinant. So it says if the operational determinant I spell determinant, A-N-T, determinant is 0. If it's 0, that implies the system of equations the system is, okay, degenerate. Okay, now we're going to do problem number 24. I have d plus 2x plus d plus 2y is equal to 1, and I've got d plus 3. D means the derivative, so that's the derivative of x plus 2x. This is the derivative of y plus 2y, plus d plus 3y is equal to t squared. And now I'm going to do the operational derivative thing. Operational derivative. D plus 2, d plus 3, d plus 2, d plus 3, and I take that and I get those guys multiplied together minus these guys multiplied together, so that's 0. Therefore, I am degenerate. This is supposed to be a t, not that it matters, so I'm degenerate. So now either I have no solutions or I have an infinite number of solutions. So those are my two possibilities. So what I'm going to do is I'm going to try to figure out which one it is, because that's what I have to do too. So if I have x prime minus 2x plus y prime plus 2y is equal to t, and I have x prime plus 3x plus y prime plus 3y is equal to t squared. Okay, so that's what I've got. And what I'm going to do is I'm going to add these two together, but I'm going to make the top one negative and add them together. When I do that, I got x plus y is equal to t squared minus t. Okay. Alright, so that looks good so far. And but the problem. If I take d plus 2 of x plus d plus 2 of y, I get the derivative of x plus y plus 2 x plus y. Well, that doesn't seem like much of anything, but over here I have x plus y is this. So if I take the derivative of x plus y, I get 2t minus 1. And if I take 2 times x plus y, I get 2t squared minus 2t. They're not equal. So that implies no solutions. So I have no solutions to that particular differential equation. Okay, if it had a solution, we're supposed to figure out how many consonants it has too also. So that's the other thing we have to do. Okay, number 26, I have d squared plus 1x plus d squared y is equal to 2e to the minus t. And I've got d squared minus 1 x plus d squared y is equal to 0. Okay, I'm going to look at the operational determinant again. And I've got d squared plus 1, d squared minus 1, d squared, d squared. So I have d to the 4th plus d squared minus d to the fourth plus d squared. So it's going to be 2d. d squared. That's going to be d squared, which is not equal to 0. So I'm not degenerate. Okay, now this d squared guy is really the characteristic equation, because see, I've got two equations that are together. They're going to have the same characteristic equation in order to have those solutions. So the d squared guy turns out to be this characteristic equation of m squared equals 0, which implies that m is equal to solution set 0, 0. So x c of t, complementary solution, homogeneous solution c1 plus c2t. Okay. Well, if that's what x is, then what's the first derivative of that? C2. What's the second derivative of that? 0. Okay. Well, that being the case, we have our two equations again. We're going to go with d squared plus 1 x plus d squared y is equal to 2e to the minus t, and we're going to come up with and d squared minus 1 x plus d squared y is equal to 0. If I subtract those two, what am I going to get? I'm going to get 2y, 2x. I'm going to get 2x is equal to 2e to the minus t. Okay, so x is going to have to equal e to the minus t. And that's basically going to have to be my particular solution. So that being the case, x of t, well, we really don't care what our solution is. All that we really care is that there are two constants for the problem. Because d squared y is equal to 0. So y is going to have to be b1 plus b2 t. And, okay, well, the bottom line is two constants, i.e. two constants. Okay, problem number 28. We have d squared plus 1x plus d squared y is equal to 2e to the minus t. We have d squared minus 1x plus d squared minus d y is equal to 0. We have an operational determinant, d squared plus 1, d squared, that's a d, minus 1, d squared minus d. And that's going to be when we cancel everything that we need to cancel, d cubed minus d squared, which is not 0. So the equation is not degenerate. Unfortunately, but if I have d squared plus 1 x plus d squared y is equal to e to the minus t, and I have d squared minus 1 x plus d squared minus d y is equal to 0, and I go and I subtract these two, what happens? Well, it looks like I get 2x minus dy is equal to 2e to the minus t. Okay, so that I don't see anything wrong with that, do you? Unfortunately, 2x minus dx is e to the minus t. Unfortunately, 2e to the minus t has to be d squared plus 1x plus d squared y. And those two are not the same. Therefore, there's no solution. Okay. Well, I guess that should have not been part 2 because that went pretty quickly, but that is the way it is.